Welcome dear students, here I am your online tutor. It's all about physics. Like and subscribe the channel as we're dealing with the chapter number 2 kinematics, the motions of objects, class 9th physics. And in this lecture I tell you the most important topic of this chapter. The topic is equations of motion. Watch the video till end because it is too much important topic and there is a lot of information in this lecture, and one must equation of motion come in the board exams. Okay students, let's start. There are three basic equations of motion for bodies moving with a uniform acceleration. These equations relate initial velocity, final velocity, acceleration, time and distance covered by a moving body. And to simplify and derive these equations of motion, we assume that the motion is along a straight line. We check a body that moves with a uniform speed. Okay student, here is a speed time graph, and this graph is too much important because without this graph you can't find out and calculate the equations of motion. So must do the practice of this graph, and it is the graph between speed and time. And as we know that the time is independent quantity and we take along it a x-axis and the speed along a vertical line y-axis. Okay, we consider a body that moving with a velocity vi and in a straight line with a uniform acceleration a, and its velocity will be vf after time t. Okay, this point is known as O and we name it as A, B, C and point T. And this line AB is the slope, and this gives us the uniform acceleration because body cover equal change of velocity in equal interval of time. That's why it is uniform, and we give the name it acceleration A. Okay, in first equation of motion we have to calculate the slope of this line AB, and by finding this slope of line AB we have to calculate the acceleration of that body. Okay, we have to calculate the slope of line AB, and first you have to know the meaning of word slope. Slope mean to find the change in y divided by change in x. Okay, and in this for equation of first equation of motion we consider this portion only. Okay, and the slope of line AB equal to change in y, and this is the y-axis. Okay, and it is the change in y BC, and divided by change in x, and it is the x-axis, so change in x is A to C. Okay, and as we know that this AC is equal to this OD, but here is a confusion that how we calculate this BC. Okay, and if we want to calculate the BC, we consider this full height B to D, and for calculating the BC we divide this portion CD from full BD. Okay, for BC equal to BD minus CD. Okay, we put BC is equal to BD minus CD. BD full this one and BC this portion. Okay, and if we subtract the CD from BD we get the BC. Okay, understand? Divided by, instead of AC we can write as OD. Okay, as we say that we have to find the relation between VF, VI, time and acceleration in first equation of motion. So BD is equal to the VF, and this BC and CD, this and this CD is equal to the vi, and this OD is equal to the time t. Okay, by putting the values, BD equal to VF and CD equal to VI and OD equal to time t. Okay, and the slope of line AB is equal to the acceleration, so we can write that acceleration equal to BD is equal to VF minus, and CD is equal to VI, and this OD is equal to the time t. Okay, it is the equation formula of acceleration, the change in velocity divided by time. Understand? And we can write it as Vf minus Vi is equal to AT, and the Vf is equal to AT plus Vi. It is the first equation of motion. Vf is equal to AT plus Vi. Okay student, now solve some examples related to the first equation of motion. First example is a car traveling at 10 meter per second accelerates uniformly at the 2 meter per second scale. Calculate its velocity at 5 seconds. Okay, given data is the car traveling uniformly at 10 meter per second, mean that it is the initial velocity Vi is equal to 10 meter per second, and car accelerate at the 2 meter per second scale, mean that it is the acceleration, and calculates its velocity at 5 seconds. Time t is equal to 5 seconds, and we have to calculate the final velocity Vf. Okay, as we know that the first equation of motion is equal to Vf is equal to Vi plus At. Okay, by putting these all values, we get the final velocity of car. Vf is equal to Vi is 10 meter per second, and the acceleration plus acceleration is 2 meter per second square, and the time t is 5 seconds. Okay, Vf equal to 10 plus 2 5s are 10, and Vf is equal to 10 plus 10 20, and the unit of velocity is meter per second, and the final velocity of car is 20 meter per second. It's here another example. Our train slow down from 80 km per hour with a uniform retardation of 2 meter per second square. How long will it take to attain speed of 20 km per hour? Given data is Vi is equal to, because train is initially moving with 80 km per hour, so Vf is equal to 80 km per hour, and the retardation is a negative of acceleration, and acceleration is equal to minus 2 meter per second square, and the final velocity is 20 kilometer per hour, 20 kilometer per hour. Okay, and we have to calculate the time. How long will it take to attain the speed? Mean we have to calculate time. Okay students, as we know that the formula of and the unit of velocity is meter per second, we have to shift this unit into meter per second, and for meter per second we multiply 80 with 1000, because in 1 kilometer there is 1000 meter, and in 1 hour there is 60 minutes and 60 seconds. Okay, and by dividing and multiplying this, we get 22.2 meter per second, and here also we multiply 20 by 1000 and divided by 60 multiplied by 60, 0 cut with 0, and 200 divided by 36 equal to 5.6 meter per second. And we have to calculate the time, and we have the data Vf, Vi and acceleration a. So we use the first equation of motion, Vf is equal to Vi plus at, but we have to find the time t. So Vf minus Vi equal to at, and we separate the time t, and Vf minus Vi divided by a. By putting the values, we get Vf is equal to 5.6 and Vi is equal to the 22.2, and the time acceleration is -2. Okay, we get the final answer, that is equal to the 8.3 seconds. Okay, if we subtract the 5.6 from 22.5, we get the negative value, because with big value there is a negative sign, and this negative sign is cut with this negative sign, and we get the time positive, because time is not negative, time is always positive. Okay, thanks for watching.